Hi, welcome back. So now we've went through the sort of prerequisites, stuff you're supposed to know. Okay, so I went through the quadrant check stuff, and I went through again how to solve basic trig equations, where that just involves sine of single x, cos of single x, and tan of single x. That sounds like a song. Anyway, sine of single x, cos of single x. Right. um, So what we're now going to do is double angle. That means instead of single x, double x here is double angle. So how's it going to work out here? So double angle formally or formulas, whatever, doesn't matter here. So what we're going to look at here, um, we're going to have things here like sine 2x or cos 2x. So you know I like getting the highlighters out here. So if you see a formula with sine 2x or cos 2x, if they're on their own, then we can solve them. But usually they're partnered up with a sin x or a cos x. We don't deal with tan x, okay? So what we're going to do is get rid of them. So we've got replacements for these. So these replacements for sine 2x, it's just 2 times sine x times cos x. So we just stick everything together here. That's fine. That's one straightforward replacement. But see, for cos 2x, you got a problem here. There's 3 replacements for cos 2x. And that's what those are there. And we read them as 2 cos squared x minus 1, 1 minus 2 sine squared x, and cos squared x minus sine squared x. So if you paid attention during the lessons, then you will get the drift. Okay, right, so we're just going to get into a wee example here. So the whole point of this was anytime you identify sine 2x, cos 2x, you're going to get rid of it and say, is it going to be that one? Is it going to be that one? Is it going to be that one? Or I've run out of colours. Is it going to be that one? So we need to make a replacement because the ones on the right hand side, they have single x. So that's what we're going to do. So we're going to solve for that. So I can see a sine 2x on the left, sine x on the right. So, and I'm solving between 0 and 360. Include 0 but not 360. Don't worry too much about that until the end. Right, here we go. Anytime here we see a 2x with sine or cosine in front of it, we're going to get rid of it. It's going to get replaced. So don't worry about that. But with sine 2x, there's only one replacement that we showed you earlier. 2 sine x cos x. Okay. Everything else stays the same in the equation. Okay. So that is a straight replacement there. Right. Okay. So what we're doing now, we're looking at these two things. That's one thing. That's another thing. Have they got anything in common apart from x's? Yes, they get sine x in common. Okay, so we're going to get involved in a process that you know all about called factorising. We're going to factor out sine x. Okay, now we factorise out sine x, what are we left with? Well, when we factorise it out, we're left with sine x, it comes out because it was common to both, and we get cos 2 cos x, so there's the 2, there's the cos x, so that accounts for that. But you're thinking to yourself, well, where does the minus 1 come from? Well, there's one lot of sine x there, so you've only got a 1 there. So that's where that comes from. Okay. So hopefully you're taking that on board. So stuff you've learnt before, you're getting hit with now. But you factorise that. Yeah. But you've got something times something, the stuff in the bracket, equals 0. The only way that is possible, if sin x is equal to 0, or the stuff in the bracket, 2 cos x minus 1, is equal to 0. Okay? You encountered that before in quadratic equations. So here, we'll get two equations here. See if you get sin x or cos x equals 0, you're always going to end up with that in double angles, unless I say otherwise, and I will in another lesson. That should be fine. So I think we're going to deal with these separately. But see the 2 cos x minus 1, I need to tidy that up. So I've technically added 1 to both sides. And to get rid of the minus 1, 0 plus 1 is 1. I've divided by 2. Cos x equals a half. That's fine. So we'll get sin x equals 0. And I've got cos x equals a half. So I'm solving for them now. Okay. Right, so there we go. Solving for both of them. So I could do them together on the same page, or, and I think I have to, see when it's equal to 0, or 1 or negative 1, just use the graph. So when sin x equals to 0, x, what they're talking about there, x is the x-axis. So where does the curve cross the x-axis? That's what I'm saying there, that's maybe an x. Where does it cross the x-axis? Well, I've highlighted there, it's 0 and 180. That's your solutions there. Right, I'm going to go back to my question here. Sorry. No, I've not included 3/6, that's fine. Sorry, you've got to question yourself at times. Just bear with me, right? So I'm not including 3/6, that's fine. So that's why I haven't highlighted it. If it was inclusive for 360, then I'd have inserted it. Right, so it's only 0 and 180. That's my two solutions there. 0 and 180. Right, the other one, cos x equals a half. I think that's going to involve the quadrant check stuff. It does. Where is cosine positive? All in cosine. Right, we've done that before, so I don't need to drag it out. We're fine there. Right, so I need to introduce a, because a is a calculator answer. So instead of cos x equals a half, it's cos a equals a half. Cos a equals a half. A equals the inverse cos of a half. A equals 60, I think. There you go. So you're all up to speed in that. You should be able to do that. Can you take the value of a equals 60? Yep. Take that value of a equals 60, and can you place it? So that's going to be an answer, and that's going to be an answer. So a is the answer itself, 60, and 360 minus 60. And hopefully you get those two. Right, so we'll get two sets of answers here. We'll get those two, and those two. Let's group them together. Okay, bring them together. You can put them in numerical order if you want. That's unimportant there. So there's for answer 0, 60, 180, 300, and we do check that they lie between 0 and 360, and it was inclusive of 0, so I think I'm fine there. Right, let's go for another one, since we're on a roll. So I hope you noticed I'm speeding up here. this isn't the basic trig stuff. So 3 sine 2x, take away 2 cos x equals 0. So it's sine 2x we're looking at here. It's going to get replaced. Okay? There's only one replacement. That's 2 sine x cos x. But notice there's a 3 at the front. Okay? So I'll put the replacement in a bracket there. Right? That's getting replaced by that. The 3's at the front. Everything else stays the same. 3 times 2 is 6. The 3 can only multiply one of the things in there. So it's 3 times its pal, 2, 6. Okay, that's what expand means, multiply. Done. Right, now it looks like I'm going for a common factor here. Well, 6 and 2 could have a common factor 2, but I'm not going to get a common factor 2, because when you take out, sometimes when we take out numerical common factors, we can run into mistakes. So I'm only interested in the trig part, the sine or cosine part. Right, so it looks like I've got cos x in common, so I'm going to take that out and see what I'm getting left with. Right, so can you see that when I take out cos x, I've got 6 sin x, take away 2. That should be in the bracket, and I should have cos x at the front. That's what it looks like I've got there. Right, so now what I'm going to do, or see here, what's that times that equals 0. The only way that's possible is if cos x is equal to 0, or the stuff in the bracket is actually equal to 0. Right? So that's what I've done now. Oh, you're always going to have sin x or cos x, unless I tell you otherwise, is equal to 0. Use the graph. Right? But the other one there, I've tidied it up. 6 sin x, take away 2 is equal to 0. Get rid of 2, take it to the other side, becomes positive 2, divide by 6, 2 over 6. 2 over 6, can you simplify that? A third. Okay, go for that. You could have left it as 2 over 6. That's fine. Right, let's solve for that. Use the graph. Where is cosine of x equals to 0? I've said before, when you're solving for x, it's in 0. Where does it cross x axis? I've highlighted there at 90 and 270. That's my solutions there for that one. Other one, sine x equals a third. I need to do a quadrant check here. I can see sine is positive, and all on sine. 180 minus a and plus a. So I need to bring on board not sine x, but sine a equals a third. Then I need to do a equals inverse sine a third. And gives a nice answer of 19.5. Can you take the 19.5? Yeah, I'm going to take that 19.5. And can you put it in there? And can you put it in there? And that'll be your two solutions for this part of the equation. There you go. It is 19.5 itself and 180 minus it. There you go. Go and bring back your other two answers from the graph that we had. What was that, 90 and 270, I think? Yep, it was. Let's bring them back on board. There you go. Fine and dandy. Okay. Right. Okay. I'm just going to fire through these. Cos 2x. Replacements for cos 2x. Right. Okay. In fact, no. I'm going to do a separate video for that. So I'm going to leave this one now, okay? Because I know you can't take too much. So this was only replacements for sine 2x. Right. So we'll do that in the next video. See you in a bit. Bye.